How are you guys? In this video, I would like to share with you 4 interesting questions about determinants. And I will leave at the end of this video 3 practice questions for you. Only the answers are provided so that you can practice and learn more. But before we start, just one slide here. I will show you what is determinant. The definition, determinant is a real number associated with each square matrix. So we have to have square matrix, 2 by 2, 3 by 3, 4 by 4, and so on. The determinant is a number. So it can be positive, negative, zero, fraction, radicals, but it should be a real number. Now for 2 by 2, we have here matrix A, B, C, D. Simple formula to find determinant, we can write it as DET or 2 vertical bars. This is determinant. So we write A, B, C, D with bars. This is different from matrix. We multiply the main diagonal AD minus the product of the other diagonal. So this is determinant, the product of the main diagonal entries minus the product of the other diagonal. Now, question number 1. Given the matrix A, sine 100 degrees, cosine 100 degrees, cosine 20 degrees, cosine 70 degrees, and we need to find 12 times determinant of A. You can just pause the video for a second or so and try it yourself. And then you can check on the next slide the details of the solution. Okay. So here we need 12 determinant of A. So easily we can find determinant of A by the formula I have shown you and then multiply by 12. So to start here, apply directly the formula of finding 2 by 2 determinants. So it will be 12, this is from the given outside, sine 100 times cosine 70 minus cosine 100 times cosine 20. Now here we see there is no formula like this in trig functions. Sine, cosine, cosine, cosine. So we have to use some formulas there. We use cofunction identity. Cofunction means we change the cosine 20 that's here in the question into sine 70. These are exactly the same numbers. So cosine 20 will be sine 90 minus the 20 there becomes sine 70 because I need here sine to use the formula down. So this is complementary function. Cosine 20 is equal to sine 70 simply. So replace cosine 20 here in the next slide, replace it by sine 70. Then we have to use this formula. Sine of u, cosine of v, this is 70, cosine of u, that's 100, sine now of 70. So I can use as sine u minus v. Okay. So on the next slide, we can continue. Now we have sine 100 cosine 70 minus cosine 100 sine 70. We replace that from cosine 20 to sine 70. So this will be sine 100 minus 70, which is sine u minus v. 100 minus 70 will be 30. Sine 30, we know that one of the special angles, it's half. So half times 12 will be 6. So this is the answer for question number 1. Let's see question number 2. Find the values of x. We have many x's there in this matrix. If the determinant of the matrix M is equal to minus 3. This is a matrix M 3 by 3 and the determinant is given minus 3. We have to find the value or values It depends of the x. So how do we start? We find the determinant first. Equals minus 3. So we establish an equation where we can find x. You can try it if you like, or at least start. Let's see. So this is the given matrix M, and this is the determinant is equal minus 3. Now we have here 3 by 3. One of the best methods, there are many methods actually, to find the determinant 3 by 3 or more. One way is to write it in triangular form. See, look at here. This is matrix, and this one is determinant. So I take the same numbers, I put 2 vertical bars, that's determinant. I try to make zeros under the main diagonal. You see the main diagonal here. So we call this triangular form. So we make a form of triangle. We can make it also up. We can change this 0. This is already 0. We can change this one 0 by using rows transformations. So this one, 1x0, I need to change this number here, 0. So just multiply row 1, this is row 1 here, 1x0, by minus 1. You can see the rules there, and then add. So multiply this by minus 1, add, you get 0 there. Multiply this by minus 1, you get minus x. Add to 0, you get minus x. Multiply by minus 1, that's 0. Add to x will stay x. Now this is already 0, so we leave it. Now we move, we finish now column 1, 1, 0, 0. I leave this one here minus x. I need this one to be 0. Just multiply row 2, this is row 2, by 1, which means nothing. Just take row 2, add to row 3, because when you add minus x to x, you get 0 directly. But you have to add x and 1 here. So x and 1 becomes x plus 1 down. Now we have triangular form. See, this is triangle here. So the determinant will be product of entries on the main diagonal. See, the determinant will be 1 times minus x times x plus 1. Just all the entries, all the elements, all the members, all the numbers on the main diagonal. So try to multiply these 3 numbers equals minus 3. Make the equation and try to find x, if you like to practice before you see the complete solution. Now, as I mentioned before, 1 minus x, x plus 1, just multiply them, just the product. See, this is triangular form. I mentioned that again. Product of entries on the main diagonal. So 1, whatever the numbers are, 1 times minus x times x plus 1 equals minus 3. Just rearrange the equation here. So this is minus x squared, minus x, minus 3, bring it on the other side, multiply with minus. You will get this equation here. You will get this equation, x squared plus x minus 3. So this is, we call this quadratic equation. And this quadratic cannot be factored. So I have to use something called, from algebra, quadratic formula. I think you know that. Some of you, they might remember it. So x will be minus b plus or minus square root of b squared minus 4ac divided by 2a. What is abc? A is the coefficient here of x squared. B is the coefficient of the x. And c is the constant minus 3. So this is the value of x now. So x will be minus 1 plus or minus square root of 13 divided by 2. Okay, let's move to question number 3. Question number 3, given a matrix E 2 by 2, 2 minus 1, 3, 0. If the determinant of E, see this is a matrix E, minus ln of x, that's logarithmic of base E, natural logarithm, multiplied by I, the identity, equals 18. If the determinant here is equal 18. So we have a subtraction here. This is E, and I is another matrix 1, 0, 0, 1, the identity. Multiply that by this number, ln of x. Subtract, find the determinant, equals 18. Then find all values of x. Really interesting question. Okay, let's start. So E is there. And I, we know 1, 0, 0, 1. So E minus ln of x. Just leave the E there. Multiply ln of x by I. So multiply, see this becomes ln of x 0, 0, ln of x. Then we subtract normally. We subtract this term minus this term. And then 3 minus 0, 3. This one minus 1 minus 0 is there. So we get this one, we have to find the determinant of this. So find the determinant of the last matrix, this one here, 2 by 2. So 2 by 2, 2 minus ln of x multiplied by minus ln of x, minus 3 becomes plus 3 equals 18 from the given. And now the idea here is how to solve this equation in logarithmic equations. So we multiply minus 2 ln of x, minus with the minus becomes plus ln squared of x, plus 3 is equal 18. Bring 18 on the other side, and then becomes minus 15. ln squared of x, you have to know that this is exactly ln of x all squared. If it is squared on the function, then it is in the whole function, ln of x all squared. It's not on the argument. X, we call it argument. Now, to factor this, to make it easy, you can factor it directly, but to make it easy, use something in algebra. We say let capital M is equal ln of x here, to make it simple. The reason I put this yellow here, just to make it simple for factoring. So this is capital M, this is M squared. So M squared minus 2M minus 15 equals 0, quadratic, easy to factor. We can see that on the next slide. You can try, if you like, find the values of M here. And then after that, you find the values of the X. Remember, we need the values of the X. But we let here, let means suppose or assume capital M is equal ln of x. Now, so we can factor this, m plus 3 times m minus 5, because when you multiply 3 plus 3 minus 5 is minus 15. When you add them, you get minus 2. So m will be minus 3 or m will be 5. Remember, we have to go back to x. So I write, instead of capital M here, ln of x is equal minus 3, ln of x is equal 5. Then I have to go back to logarithmic function and use this important rule. We call it exponential and logarithmic conversion rule. If you have any log, y equals log base a of x, if and only if x equals a to the power y. So we can go from logarithms to exponential, or from exponential to logarithm. This is logarithm base e. So directly I will say x equals e to the power minus 3. And this one, x equals e to the power 5. This one here, negative exponents, also from algebra. This equals 1 over e cubed is the answer. Or x equals 5. These are the values of the x. So there are two values of the x in this question, 1 over e cubed or x equal e to the power 5. Let's see the last question, which is very, very interesting. Given the matrices, now we have here two matrices, A and B, And we have some log, some base natural logarithm base e, we have pi, we have cosine pi, we have tan inverse 1. Okay, now we need to find the values of the x if the determinant of A plus the determinant of B equals 78. You can see this question on the thumbnail. Okay, so that's the same question. So find the determinant of A 2 by 2, find the determinant of B 2 by 2, add the values, the numbers that you get, equals 78. Then you can find X. Also, you can pause here if you like. It's very nice to try before you see the solution. Okay, let's go. Now first, I said here, find the determinant of each matrix. Then, after you find the determinant, the sum is equal to 78. The sum of what? Determinant of A plus determinant of B. Now, determinant of A, 2 by 2. Multiply the main diagonal. This is 81, 3 power 4. Multiply that by minus ln of E cubed. Minus this one, 16 to the power minus half, 1 over square root of 16, multiplied by pi. This one is 4 by the properties of logarithm. And this one is 3, and there is a minus, so it's minus 3. Square root of 16 is exactly 4 multiplied by pi. So when you simplify the numbers here, minus 12 minus pi over 4, leave it. This number here, that's a number, real number. This is determinant of A. Leave it. Now let's go to B. Tan inverse 1. Tan inverse 1, what is the angle whose tangent is 1? This angle is 45 degrees. So I will write pi over 4. Log of 110 is 1 by the property. 5x is there. Cosine pi is minus 1. And there is a minus, so that will be plus 1. Now find the determinant of B. Pi over 4 times 1 is pi over 4 minus 5x. Now just look here. What do we have to do? We have to take this value here, determinant of A, and we have to take this value, determinant of B, and then we add them. Equals 78. And then you can figure out the value of X. Let's see. Really interesting, this one. Determinant of A we have found. Determinant of B we have found. Now use the equation from the given. Determinant of A plus determinant of B is equal to 78. So this one is minus 12 minus pi over 4. And this one, pi over 4 minus 5x equals 78. Add the equations. This will cancel out. So minus 12 minus 5x is equal to 78. Take minus 12 on the other side. When you add, you get 90. And then divide by minus 5. So x will be minus 18. That's question number 4. Now we come to practice. Also, the practices, I can tell you, they are really nice and interesting. Each one you have to think of. Just read it carefully at your leisure time. Given small a, small b, find the determinant, practice number 1. Practice number 2, I gave you here the determinant of 2 by 2. I need the determinant of 3 by 3. So nice. And practice number 3, given matrices A and B, find the determinant of the product BA. The answers you can find in this last slide, practice number 1, 2, 3, and the answers. Thank you for watching, and see you again in another video. Thank you very much.